Okay, let's pick up where we left off last time. We had two end nodes. We connected them with the media, and we've set the IP address for both, and we were able to monitor and observe a frame that goes between these two end nodes by using an ICMP message. Now, the limitation this network gives us is basically simple. Each one of these has one port, so it is a point-to-point connection. What if I needed more than one computer to access this web server? What can we do about it? Well, let's start a new file for this. So let's close this simulation here. Let's go to real time, delete the scenario we had, save everything we already had. Right, so I'm hitting save. Now I'm going to create a new file, and I'm going to say yes. And now we have a new file, and we're going to recreate kind of the same scenario, but this time we want multiple PCs to be able to access the server. We're going to do this at layer 1 in terms of the internetworking, or the device that will allow the internetworking. What we will use, in other words, is a hub, okay, which is a multi-port repeater. Okay, so we could start with the hub right here. So as you can see here, where I'm going here is the categories. So you have routers, switches, hubs, okay? Then you have wireless devices. We're not doing any of that. We're just going to pick up a hub, a wired hub, okay? And so I'm going to pick that hub and put it right here, okay? Now, if I want to look at physically what the hub looks like, now notice by putting my mouse on it, as you can see, it has 6 ports, okay? And they're compatible to Ethernet. Now, if I double click here, you can see it's a simple hub, and the switch is on. You can see that right here. So let me see if I can zoom in a little more. Here you go. And it's got your 6 ports here. And you can update and upgrade any other switches you want. I mean, any other interfaces you want right here. So you got 4 slots in here, okay? So this is a customizable hub if you wanted to do that. Now remember, this hub is a layer 1 device, okay? So it basically, if anything comes through one port, it gets transmitted on all other ports. That term is called flooding. So let me repeat that again. It's flooding. So whatever incoming message, then all other ports will transmit out. That means everybody connected also on any of these ports are not only in the same broadcast domain, but they're on the same collision domain. So remember that, take notes. All devices connected here will be on the same collision domain, as well as belonging to the same broadcast domain, okay? All right, so let's go ahead and put a router, let's go ahead and put a server and a bunch of computers. So I'm going to pick a server. I'm going to put it right here. And I'm going to pick a few PCs. I'm going to put one here, and one here. So I've got 3 PCs that want to access the server. Remember the challenge we had prior to this? The server only had 1 port, and a PC only has 1 port interface, right? Ethernet port. So with the hub, we are going to basically have a star configuration, visually speaking. In reality, any connecting to a hub, we're in a bus configuration. They're all sharing the same media, which means if any of these PCs or the server is broadcasting out or transmitting, all others cannot transmit out on the media. Otherwise, you're going to end up with a collision. Now, the hub does not manage collision. Okay? So what's going to happen? Well, all PCs and all servers are going to be listening to the media once we connect everything. And if they see a carrier, which basically is the way you carry a transmission or information. So a carrier is basically a signal that you modulate over it the actual transmission that you want. Okay? And so what's going to happen is if there is a carrier on the media, that means somebody's transmitting. And in that case, you don't, as a unit, as an end unit, as an end node, you don't want to transmit. So you're always promiscuously listening to the media for carriers. Should you want to transmit and you see that no one is transmitting, go ahead and put your frame out. Now remember, we're at frame level here, within the same collision domain here. Okay? All right, well, let's connect these guys. And let's go to the connection. Now, you could use the Thunderbolt here. As you can see, if I do here, let me select the Thunderbolt and go from here to here. Notice it's not even telling me which port to port, but it will automatically connect for you. If you want to connect yourself manually, notice with the Thunderbolt that was in here, it gave you a straight through cable. This, as you can see, that's a straight through. So it automatically picked for you the appropriate cable, either be it Cat 6, Cat 5, whatever it is, with RJ45 on either end. Okay, but the configuration is a straight through versus a crossover. Remember, in the previous lab, we used crossover when we connected a PC to a server. That's because they were like devices. A hub and a PC are not alike. A hub is a layer 1 device. A PC is a layer 3 device. Remember that. So that's why you're able to use a straight through. Now, if you want to manually use a straight through, you can go ahead from Fast Ethernet 0. Notice here I'm going to have Fast Ethernet 0 for the hub is already taken when you use that Thunderbolt. So you have Fast Ethernet 1. Let's do it again. So if I go from here to here, Fast Ethernet 0 for this PC, notice what's available to me, right? So every time you use, you could use any of these. So I'm going to go Fast Ethernet 2. Well, let's do the same thing with the server. Now, the server, again, is a layer 3 device. And I'm going to click here, and I'm going to pick 5. So you don't have to go sequentially, right? All right, so that's the amount of flexibility you have here in terms of which port to use. And again, remember, if the server is transmitting anything, it will flood the hub. So that means all other ports other than the receiving port will transmit that frame, which means that frame will be replicated and transmitted on all of them. We'll get to see this ourselves, okay, in the simulation when we transmit the frames between end nodes. So we need to do something very important here. All of these need to belong to the same domain: collision and broadcast. Okay? Now, they are automatically in the same collision domain, the fact that they're connected physically together through a hub. Next, how do you make sure that they're in the same broadcast domain? Well, you're going to have to set some IP address, layer 3. Okay? And what's going to happen is you're going to be mapping layer 3 addresses to the physical addresses. And each computer, each server, will have what we call an ARP table. We can verify that later on. That maps or basically matches a MAC to an IP. Okay? So that's something we can investigate later on and look at the ARP tables for the end nodes. But right now, the objective is to make sure that all of these can communicate to the server. And we're going to make this server a web server. That means any of these PCs will be able to pull that web page being hosted by the server. So for this lesson, to do that, the upcoming lesson, we're going to go ahead and watch the frames, how they move, as we either do an ICMP or a web page request, whatever service we want. Okay. All right. So for now, remember, I need all of these to be in the same domain. Notice There are no IP addresses set for these. All right, so I can go to this PC here. Let's start with the server. Let me go over here and go to config fast Ethernet 0. And this is where you can say, okay, what will be the network address plus the host address. I like the private one address 192.168.10, and I'm going to call this one .1. Okay, so always use the lowest values within your group, either for a port for a router, if you have a router. That will be your default gateway, by the way. And the next to it will be for the service. That's, it's your choice. As long as throughout your network, all your IP addresses are unique, okay? Otherwise, you're going to have a clash. Let's go to the PC here. Again, same thing, configuration, and go to fast Ethernet 0. And under IPv4, 192.168.10. Again, we will have a lesson on IP addresses, IPv4, and another lesson on IPv6. So bear with me right now. Just replicate what I'm doing. Now, let's suppose I made a mistake and I type 1. And notice what I get. I get this address is already used in the network, okay? That's really good. Now, in the real world, you're not going to get that message until it's too late when you're trying to connect. So the simulator is really working with you. So be careful in a real lab. Jot down, have a piece of paper with a map of all your IP addresses for all devices. Highly recommended you do that. Okay, so 192.168.10.2 for this one. Let's do a .3 for this one. Let's go to config. By the way, you could do this right here. So if you go to desktop, you can go to IP config right here. You could do it right here. 192.168.10.3. So there are plenty of places where you can actually do this right there. Now, again, we will be covering default gateways and DNS servers when we get there. Okay. So right now, really, we're keeping the example as simple as possible. Okay. And we just need to set up the IP address for our end nodes. And again, you could do it from the desktop, go to IP configuration, or you can go to config and go to fast Ethernet and do it right here. And that would be 192.168.10.4, right? So if you click here anywhere in the space, the subnet mask is automatically assigned as a Class C subnet mask. Okay, that's the default subnet Class C subnet mask. Are we going to use non-default subnet masks in the future? Absolutely. Right, so it depends on our strategy. Right now, this gives us basically 256 combination. However, 2 addresses will be taken out. One will be for the broadcast and one will be for the network itself. So you cannot use 192.168.10.0 to identify a device. And you cannot use the last address within that block as 192.168.10.255 for a device. .0 is to identify this network. .255 is reserved for broadcast. Okay? So the last valid, and let's do it. The last valid one will be 254. Okay? You cannot use 255. Now watch what happens if I try to do 255. I get invalid subnet mask. Okay? Now, 192.168.10.0. Now let's suppose I did that. I get invalid subnet mask. Okay? Those are the 2 extremes you can't use. And well, let's say I didn't know anything about IP and I did something like this, 168.10.200. Okay? Well, that's fine. Let's 300. That's beyond range, and you get it invalid, right? Because your max value is 255, right? 200 is fine. Nobody else has 200. Remember, the max address 254 for a physical address, logical address for a physical end node. So 192.168.10.254. So let's pick the last one there, right there. Good. No news is good news, so we're good there. All right, so now let's pay attention here. Let me just hover my mouse here. Notice I have an IP address. Notice I have an IP address for that one. I have an IP address for this one, which is 254, right? And this one should be 3 as a host. Good. I can ping between them. So I can go to this PC here. Let's go to the desktop. Let's ping the last one, 192.168.10.254. Okay? And there you have it. Now, here's another thing. Remember I mentioned an ARP table? Okay? So what you could do is you can actually look at the ARP table for this computer in particular, ARP-A. So this will be the command for it. And notice it recognizes that there is a computer on this network called 254. And remember where I am. I'm right here. ipconfig shows you where you are. Okay? I am .2. But when I do ARP-A, I can see that I have access to 254. And you know what? It knows that because when I sent that ICMP message, 254 responded back. Okay? And the fact that it responded back, I know that it exists on this network, or at least within my own collision domain. And if that's the case, I can actually put it in my ARP table. And ARP stands for Address Resolution Protocol, right? So what it allows me to do is assign an IP address to a MAC address. Now that's important because if I get a frame, and we've seen that in the previous lesson, in that frame there will be a MAC address that says, hey, I'm the one who sent this. Aha. Then I know logically what IP address belongs to that. Okay, well that leaves the gate open for man-in-the-middle attacks. That's another topic, okay? All right, so now that we've seen that this can ping that one, now let's say if it pings the server. Okay, so let's go ahead and ping the server, 192.168.10.1. And to prove the point, let's go ahead and do an ARP-A and see if it updated its ARP table. Now, in the real world, this is done automatically. Here, it's done manually. Every time you ping, you're also updating your ARP table. So let's do an ARP-A. And notice now I have 2 addresses in my ARP table. Okay? So that's one quick lesson as far as ARP is concerned. So the more I get responses within the same collision domain from other devices, my ARP table gets populated. Can I edit what's in the ARP table? Yes. Can I delete an entry? Absolutely. That's another lab. All right. Okay, so now I want to make sure that I can access the service this server is supposed to do. Well, let's make sure that we have that service. So let's go to services, and we're going to go to HTTP right here, and you can see it's on. So it's already turned on, and it has an index.html page that it hosts, plus other pages. Let's look at it again. You know what? Let's add something in there in the page. Now, this is the default page they put in the simulator. And I'm going to type hi there. Welcome to DrewProf Crazy Class. And I'm going to add it in there, save it. There is already a file with the same name, overwrite, and I'm going to say yes. Okay? Let's see if it appears. So what I'm going to do is go on PC 0. You can do this anywhere. And go to desktop. So let me just close this and go to the web browser, right? And let's go ahead and do a 192.168.10.1. Let's see if we get that. And sure enough, welcome to the Cisco Packet Tracer. And again, anything that I edited on that page, hi there, welcome to DrewProf Crazy Class. Okay, let me put a comma there. So I'm going to go back and edit my web page. And where it says hi there, let me put a comma. And this is within the body of the HTML page. And I'm going to say yes. And let's see if other computers within the network access the same web page. We're going to go here. Remember, I'm on another computer, and I'm going to point to the server. Notice the server does not have a name like www.myserver.com, right? So it hasn't been resolved. We didn't set up anything for that, so you're going to have to access it using an IP address. So 192.168.10.1, right? So, and notice server reset connection, okay. Oh, .2, I tapped the wrong one, right? So .2, that's not a server. .1, that's good. It's a good thing we made a mistake. Hit go, here you go. And notice the comma now is showing up, right? And we can see that this is fun. You can go to your server and update the web page you wanna show, right? So you can do whatever you want in your lab as you replicate what we just did. Okay, I want to make sure this computer here also can access it. And 192.168.10.1, right? Not .2, not .3. None of those are hosting a web page, right? So this one, this one does. Perfect. So I hope you learned a lot from this. And the next lesson, we're going to look at the simulation. We're going to reuse this file to look at how the frames move. We're going to do some ICMPs messages, and then we're going to use the step-by-step simulator and look at the actual frames to observe what they're doing. Fantastic. See you for the next lesson.